Oke, selamat siang. Kita akan mulai perkuliahan uh, mikroprosesornya ya. Jadi mikroprosesor ini kuliahnya saya buat semi online karena saya takut apabila ada yang tidak dapat hadir gitu ya. Jadi dapat mengikutinya secara uh, online seperti itu via YouTube ya. Jadi saya sudah uh, apa namanya uh, streaming di sini. Saya sudah streaming, lalu kemudian saya saya buat agak ini fleksibel, jadi teman-teman bisa bisa mengikutinya tanpa terkecuali seperti itu. Fleksibel, jadi teman-teman bisa mengikutinya tanpa terkecuali seperti itu. Oke, mungkin saya akan masukkan kodenya. Saya masukkan dulu kodenya. Oke, kita mulai perkuliahannya ya. So basically this lecture will be held in English because of we have one international student. So I hope that you guys already familiar with an English, and we try to do the communication maybe using what is it? We call it as a lecture class, yeah, and somehow I will try to guide you in the practice class. For your information, this practice class will be guided by Septian as a assistant coordinator, yeah, and then he will arrange the schedule for the assistant class, and I hope that this schedule will cope online learning. So I hope that the task that being given in the assistant class will not make you suffer. It means that it is not hard enough, but it is also because I demand Septian to give you the question beforehand, before you are going to have a class, I mean assistant class. Okay, so we continue our discussion. Oh yeah, before I start, I already upload several videos that related with programming technique, but it is more about the introduction. And today we are talking about the what is it? Typical technical firm about the microprocessor 8085. So before we move further in the instruction, we move further in the programming technique, we should know about the physical features or physical examination about the microprocessor 8085 itself. Okay, we continue about the lecture. So basically 8085 has 39, almost 40. We call it as a 40 pins. Okay, and those pin will be divided by its function. For example, one pin is from the oscillator. Yeah, we call it as an oscillator because it has function to oscillate, yeah, to the oscillation, and we use the crystal and cope with several inductor and capacitor. The goal is for do the oscillation, generate the pulse, so then the 8085 able to work. Okay, and then we have a high order bus, and these two guys here is actually the data. Yeah, I already mentioned in the previous slide, but it is okay to remind you about the function of the pins 8085 itself. And we also have a 37 pin, which is clock, sorry, clock, yeah, which is output from the crystal from pin 1 and pin 2 here. And then we have a SID and SOD. This is for the serial communication. And we have several priority of interrupt here. We have a trap. This is the first priority, second priority, third priority, and then the fourth priority. And we have a fifth priority, which is the list of the priority. This is the what is it? The master. I mean the higher priority, higher order priority. Then this one is lower order priority, and this is the lowest, and this is the highest. The trap is the highest. Okay, and then we have interrupt acknowledge, which is sending the signal out of interrupt priority. Oh, by the way, do you know what this interrupt means? Okay, then interrupt means that you guys do something, yeah, do the activities based on the priority. Okay, when microprocessor yelling the routine and then you do the interrupt, meaning that the routine should be stopped for a moment, and then the interrupt will be granted access to do the doing, to do the process inside the microprocessor as a priority, as a VIP, very, very important person. So the ongoing process will be held for a moment until the interrupt session is finished, and then after that, after it is finished, then the routine that already held continued. Yeah, continued. Okay, and then we have a ready, hold, and hold acknowledge, which is responsible for the external device communication. We have a translate enable, which is also related with the external device communication, fetch the memory, data from the memory. We have a IOM, which is uh, able to choose whether fetching data from the internal memory or the external memory. We have a read-write signals here. Reading means that from the outside, data goes to inside. Reading something, meaning that fetching data from the outside to inside. Write meaning that fetching data from the inside to outside. Okay, and then 29 till 33, not till there, but 29 and 33, it is about the status signal, whether it is interrupt, whether it is hold, whether it is so on and so forth. Okay, and 36, it is related with the reset. Yeah, reset in, and then 3 is the out signal of the reset. Whenever the reset pulse, yeah, reset trigger pulse being ordered, and then the pin number 3 will give the status. So then the external device able to notice what happened inside the 8085. Okay, these are the general comprehension of 8085, and then we move to the details. So we are going to discuss about the function, the specific function of all the pins of 8085 itself. So this is the pin number 1 and number 2, which is related with the clock. Yeah. We call it as a clock. Yeah. Actually, this is pulse. Yeah, for make the 8085 make the microprocessor able to work. You know, as if it is a human that has a human heart. So pin 1 and 2, it is the aorta or maybe the vein, and the crystal is the, we call it as a heart of the microprocessors that always beating. Yeah, it has a heartbeat. So heartbeat meaning the pulse that able to uh what is it, make the blood in the vein is flowing. Same, whenever the blood in the body is flowing through the vein and then goes to brain, goes to another part of human, so it can make a movement, can make uh, human alive. Okay, because of the simple heartbeat on the heart. So same with the crystal clock here, this one, this guy right here, give the pulse, give the order to the flip-flop here, and then flip-flop going through all the systems, all the process, all the transistors, all the ICs on the microprocessor, so that they can work. This is the simple analogy of the clock signal. So how about the frequency? Frequency is around about the 3 megahertz. Yeah. And then the crystal is made from inductor and capacitor. Yeah. Or maybe resistor and capacitor. And it is able to use this kind of what is it, component in order to create the oscillation. Yeah, oscillation signal, which is sinusoid. Yeah, and it will be have a period, and it will be have a frequency. Okay, and then we come to the pin number 3. So pin number 3, yeah, we move to pin number 3, which is reset out signal, which indicates that CPU is being reset. Okay, when it is high, system is reset. The signal is synchronized to the processor's clock and lasts for the integral number of clock periods. When the reset out signals go slow, the process begins. Okay, so simply saying, if you want to reset your microprocessor, yeah, and then the reset signal as a notification becoming high, meaning that your microprocessor is indicates that it is being resetted. Okay. Okay. Until when? Yeah, until of course the reset out signal goes low. Okay. About pin number 4 and number 5. So it is related with the serial out data and serial in data. So pin are associated with the serial input output, yeah, in order to have communication with the external device. We already discussed these pins, yeah, in the serial data transmission in previous slide, if I'm not mistaken. But it is okay. Then I will make it further explanation when the time is ripe later on. Yeah. The SOT, serial output data, can deliver the serial data stream to the peripheral device, or maybe we call it as a external device. On the executing SIM, central interrupt, set interrupt mask instruction, if bit D6 data number 7, meaning D6 is data number 7, D1 is data number 1, is set to 1. The content of D7, the last bit, yeah, set or being reset of the accumulator is latched on the SOT pin. So here we are talking about the set interrupt mask instruction. So how to set it? Just use the D6 set into 1 and content D7 being set or reset. Okay. Whenever executing SIM, set interrupt mask here, if, yeah, this is the diagram of what I told you in previous session. This is the accumulator. D1 should be set into 1, and then this is the flip-flop for the SOT, and then if SOT is equals to 0 or 1, then it indicate the interrupt mask active. So after that, the data on the SID line pin 5 floats into accumulator at bit D7 whenever a RIM instruction is executed. Okay, so this is the RIM, read internal memory, is executed. Then the data, yeah, pin 5 being loaded to D7 here. Okay. And then we are discussing about the pin number 6 to number 11. So it is related with the priority of interrupt. This guys here is trap is the first priority. Reset 7.5 is second priority, and so on and so forth until the pin number 10, which is interrupt, yeah, which is fifth priority. So the trap is the highest priority, and the interrupt ENTR is the lowest priority. The priority level is of importance if two or more interrupt become active at the same time. Okay, the trap is non-maskable interrupt. It is both age and level sensitive. So, non-maskable interrupt meaning that trap cannot be set using software. So, only way to set the trap interrupt is using the hardware. The interrupt, which is trap reset 7.5, reset 6.5, and reset 5.5 are also called vector interrupts. which is as its interrupt has fixed memory location. Yeah, it is meaning that it has a vector location for the transfer of control from the normal execution of routine. So the vector location, all these interrupt are given in table here. This is the vector locations. Yeah. Soon as any of these pins 6 to 10 are active high, yeah, active mean high, having pulse 1, the external circuit 8085 stop the normal execution of the program, and the program control is transferred to the corresponding memory location. It is. So again, interrupt number 10, which is least importance of our function here, is the general purpose interrupt that has a lowest priority. As soon as pin number 10 is high, the microprocessor stop the execution of normal program, and after completing the instruction at hand, it goes to call instruction. So in the interrupt is enabled or disabled by the instruction ET, or enable interrupts, or DI, disable interrupts, respectively. So the pin number 11 is the acknowledge interrupt signal. Low logic 0 to this point indicates that the microprocessor has acknowledged the request from the peripheral device. So it is also used to activate the interrupt controller. Yeah. And then we have pin number 12 to 19, 21 to 28. Pin number 12 to 19 is actually the address and data from bidirectional multiplex address, or the data bus. So the least significant bit, 8 bit from the memory address, input output address, appear on the bus during the first T state of the machine cycle. Later on, we will discuss the T state machine cycle. If you uh, wonder why T states and what is T states, you can search by yourself. What is T states? What T states condition? And then it becomes the data bus that during the next T states. The pin 21 to 28, it is the address for the unidirectional, and most significantly 8-bit memory address, or 8-bit of the input output address. So the remaining of the most significant bit here being combined with the 80 until 87 in the form of address, which is we currently right now has a 16-bit wide address. Okay, this is the pin 29 until 33. It is related with the status signal. So when S1 is 1 and S0 is 1, and then you have a opcode fast, control signal is read, active flow is actually equals to 0, and the memory read when S1 and S0 1 and 0, and control signal is active flow equals to 0. So this is the memory read, this one is memory write, and we also have a input output read and input output write. But you know that the guy here and this guy here, it is related with the external or internal device. Whenever input output pin goes low, meaning that the microprocessor will access internal device. And vice versa, whenever this guy is here, the pin in here, which is input output pin, goes high, then the microprocessor will fetch, yeah, will dealing with the external device. Okay, and then we are talking about the interrupt acknowledge. Yeah. So this one is interrupt acknowledge, which is the control signal of interrupt acknowledge is low, which is active low. If it is uh, put the interrupt acknowledge low here, meaning that you guys asking the interrupt acknowledge. Yeah. And then after that halt, which is make the microprocessor halt, not doing anything, pause, and we have a hold meaning that there is an activity, but read and write activities being hold until all the ingredients, all the specification of the communication between internal device already sufficient enough, then the hold will be uh, banish and then change into the ready status. Okay, and then after that we have a high impedance. Yeah, we call it high Z, meaning that high impedance. High impedance meaning that it is the signal unable to reach the microprocessor and vice versa. And then after that, the status will be neglected, both hold and reset. But the control signal play the main role here as a controller. So whenever it goes hold machine cycle, then the read and write pin will be high impedance. Okay, and then the control signal of reset, meaning that the microcontroller being reset, yeah, forcefully reset by occasion, then the control signal of it condition will be one or high in the interrupt acknowledge. So here X meaning that unspecified, it means that yeah, whatever condition has, so it means that unspecified. Okay, this is the pin number 30, which is ALE, address latch enable terminal. When this signal is high, so that the information carried on the multiplex address or data bus, which is 80 to 87, yeah, and then the data bus 80 to 87 is actually the lower 8 bit of the address. So it also enable the low order address 80 to 87, least significant bit, from the multiplex address or data bus to let's either into the memory or the external latch. The ALE signal spirits the low order address and data bus from the multiplex address or data bus. So simply saying, address latch enable is the control, yeah, control signal that indicates when the data 80 until 87 being formed as a data, or 80 to 87 being formed as a address. So the role of the ALE signal is very important in here. So, for example, this is the additional peripheral, which is help the microprocessor 8085 to separate the data and the address. Okay. So we have pin 31, 32, and 34, which is read-write signal. So per pin 31 and 32 are the two common control signal, or write and read respectively. The pin 34 carried the input-output M signal, which is one of the status signals. The other status signals are S0 and S1, discussed earlier. A low write signal generated by microprocessor send data to the input-output device or memory. Similarly, a low read signal generated by microprocessor read or receive the data from input-output device or memory location. The input-output M signal indicates whether the address on the address bus is meant for input-output device. However, a low level to the signal indicates that the address on the address bus is meant for memory location. The read-write input-output signal functions together. So this is the read signal, which is inside the pin number 35, which is forced microprocessor to wait till data outcome yeah, become available for the memory or input output devices. The signal is indeed to synchronize the speed of microprocessor with input output device or memory, as the memory or input device are not as fast as microprocessors. When the read signal is low, the microprocessor waits till the ready signal is 1 or high. As soon as ready signal is high, the microprocessor knows that the data are available from the memory or input devices. This is the pin number 36, which is reset button, provided externally, or it may be operated directly from the other source. When this signal is low, momentarily, the CPU will reset the program counter, instruction register, and all interrupts except trap are disabled. SOD signal becomes low data, and the control bus is flooded. When this signal goes high, the data processing begin. And then finally we move to pin 37. So this pin carries clock out signal. It is to derived from the on-chip oscillator. Yeah. So this is the pin 38 till 39. So the pin number 38 till 39 are the hold and hold acknowledge. Signal This signal are used direct memory access operation, as shown as the figure beside. When any input-output device indicate the data are ready for TMA transfer, then a hold signal is sent by TMA controller to the 8085 microprocessors. It is in fact as a request signal from the TMA controller to the microprocessor. It is. The microprocessor then send the signal to TMA controller back, indicating that the microprocessor has received and request from the input output device and will relinquish the address, data, and control bus after completing the current instruction. The TMA controller thus carried out the data transfer. A low hold signal will return the control to the microprocessor after the TMA controller finished their job transfer the data. So by using this kind of arrangement, the communication and the data transfer will be faster than the usual thing. Not only faster, but the container in the TMA controller will be higher than the, we call it as a normal transfer. Okay. So those things are the, what is it? The specific feature of 8085 technically, yeah, physically and technically. So I hope that you guys enjoy the shows, and then later on I will, what is it? I will put the other videos that related with the instruction set of 8085 later on, yeah.